Hello everyone, this is Feroza and I am going to explain about digital image processing using MATLAB. First we will know what is an image. An image is a single picture which represents something. That is, an image will be having some information in it. Then comes the image processing. Here we will change the nature of the image by applying some commands on a image. The nature of the image can be changed in two ways. One is either by human interpretation or by machine interpretation. Human interpretation, it involves noise, that is adding noise, then blurring the image, and machine interpretation, it is nothing but watermarking of the images and finding the edges of the images. There are variety of applications where digital image processing is used. It is used in agriculture, forensic science, industry, inspection of paper samples, fingerprint analysis, sharpening of images, deblurring of images, and many more. Here this is a window where we will be writing some commands which has to be performed on the images. This is a startup window of a MATLAB. Here we will write the commands. This is a command history, this is a command window. All the commands which we have typed in the command window will be stored here in the command history, and this is the current directory which we are using. Here this is a MATLAB tool. Here we will write the images commands. Here we will write the commands which will be stored in the command history. Whenever we want to know which command we have typed, or we just don't want to type here a command and we want to we can take from this here like this. Then next comes the steps which are involved in the processing of the image. The first step is acquiring of the image, then pre-processing, next segmentation, then representation and description, and then next is the recognition and interpretation. Acquiring the image, it is nothing but reading the image from the disk, camera or CCD. Pre-processing involves improving quality of the image, removing noise and removing blur, etc. Segmentation is nothing but applying algorithms to identify different objects, cropping of images. Then comes representation and description, where we will extract the particular features to differentiate the images, and identifying textures, analysis, shape, curves, holes and corners. In recognition and interpretation part, we will do the analysis of result by assigning labels to the objects based on the descriptor, that is previous step, and assigning meanings to those labels. Here these are some commands, basic commands which we will be using on the images. First is reading the image, then displaying of the image, writing the image to the disk, then this is for knowing the size of the image, then info of the image, that is information to know the details of the image, and this is nothing but complementing the image. I'll be showing here how to read the image in MATLAB tool. Just I'll clear the screen here. So I'll initialize it as I is equal to I am read, then I'll read a inbuilt image cameraman which is in TIFF format, then I'll complete it. Now I want to display the image which I have read, so I am show, then I which I have initialized, it will display the image. Here the image is displayed. Now suppose I'll read one more image, Z is equal to I am read, then rice dot png here. Okay, now again I want to display this image Z. So rice is displayed here, rice is displayed, but what happens is it is displayed on the previous window where cameraman was displayed. Now we want to display both the images in a different window. So what I'll do here is I'll read the cameraman image. Now I will display this on a separate window. So I'll type here figure comma I am show. So we will get here, sorry, here it is, I am I, cameraman is read by I and rice is read by Z. So here like this. So I will get here in first window I got rice image, and in second window I got the cameraman image. Then next is types of images. There are three types of images. First one is binary, grayscale and RGB image. Here binary images, in binary images we'll see either black or white color. So here each pixel is in black or white. We only need 1 bit per pixel because there are only 2 possible values for each pixel, suitable for text and fingerprints, architectural plans. And here grayscale image, each pixel is a shade of gray from 0, that is black, to 255, that is white. Each pixel is represented by 8 bits, that is 1 byte, and distribution of black and white pixels is present here. Then next comes the RGB image, that is called as a red, green, blue, or it is called as true color. Here each pixel has a particular color and the color is described by the amount of red, green and blue in it. There are total 255:3, that is equal to 16 million colors present here. The total number of bits required for each pixel is 24. Therefore such images are also called as 24-bit colored images. And here comes the arithmetic operation on the images. So we can add a constant to a image or we can add two images. Here 128 is a constant which is being added to each of the pixel in one of the input images with corresponding pixel in other input image and returns the sum in corresponding pixel of output image. So here either you can write I is equal to C plus 128 or I is equal to IM C comma 128. I'll show this in a MATLAB toolbox. So here I'll read cameraman image, then I'll take some another character or variable Z. So I want to add IM add I plus 128. Then take on yara sorry Z is equal to IM add I plus 128. Sorry, it is I comma 128. I have wrote the command wrong. Here it is I comma 128. Now display this image. So display, here I'll display it. See here, this is when we add a constant. Earlier we have got some different image. This was the real image. When we have added 128 to the image, then we got this type of image. Similarly we can add two images. Here By writing this we can add two images. I'll add the two images. Here again I'll read these two images. Like first one, I'll read I is equal to I am read, then cameraman dot tiff, then mm, then I'll read j is equal to I am read rice dot png. Now I'll add, so I'll take z is equal to I am add I comma j. Now I'll display it. So display it, see here these are rice grains and this is a cameraman. I have added the two images. Then similarly we can perform subtraction, then multiplication and division, and even complement. In division what happens is we can perform division even by applying the multiply command. In division we want to divide the image by a constant 2, then even we can multiply the even we can use the command multiply by writing 1 over 2. It is like dividing by 2. Multiplication by 1 by 2 is nothing but dividing by 2. Now comes the types of noise. There are 4 types of noise which can be introduced in a image: salt and pepper noise, speckle noise, then Gaussian noise, periodic noise. I'll show one command of adding the salt and pepper noise. Here I will add salt and pepper noise here. Suppose I'll read a image again. I'll read the same cameraman image, then I'll add the salt and pepper noise. I'll take this, so type here, paste here. Now my image is I here, not A. Noise I, then here salt and pepper. Here salt and pepper I am writing here because I want to introduce salt and pepper noise. Now I'll display it. So display it, I have initialized by SP, so I'll write here SP. See here, these dots are nothing but the noise which is added in the original image of the cameraman. Now if you want to remove the noise from a image which we have added, now salt and pepper noise I have added, there are two methods. One is the low pass method and another is, one more is nothing but the median filter. Two methods are there, two filters we can use to remove the speckle noise, like to remove the noise by the low pass filter. We have to use these two commands, and whenever we are applying median filter we have to use this command. The next is color formats. There are 3 color formats. One is RGB, red, green, blue, this one HSV, hue saturation value, and the last one is NTSC, and one more is YIQ. So again, whenever we are performing any operation on an image, first we have to convert the image to we have to convert the image to gray level, that is we have to convert the image to grayscale, then only we can perform any of the images, any of the operations on an image. If we apply directly any operation on the color image, then it will be not done. First we have to convert the RGB image to gray. And here one, this YIQ, it is rarely used in some countries like YIQ or NTSC. It is used in some countries like America in television transmission. And here HSV cannot be changed back to YIQ or RGB. Once we convert the image to HSV, we cannot change